Okay, so we want to do 48 and 10.2, which is this scary, horrible thing with decimals in it, right?
Yeah.
Okay, so putting aside the scary, horrible thing with decimals takes a step, right? So I should think to myself, okay, personally, not real great with decimals, right? Much better with fractions. You guys realize you've made that transition?
Yeah.
You all were like, at the beginning, you were like, I can't work in fractions, I need to turn them into decimals. And now you're all like, whoa, decimals? Hang on. Let's move them to fractions.
Yeah. Unless it's money.
Unless it's money. All right, so let's move them to fractions. What's 0.20 as a fraction? Yeah, 20 over 100. So I just rewrite, first things first, as I'm just replacing these guys with whatever they are over 100, right?
Right.
Okay, so my first one is 4 times the square root of 20 over 100. My second one is 3 times the square root of 90 over 100. Then I've got minus 7. How about this guy?
Same thing.
80 over 100. And this last guy is 160 over 100. Cool. All right. So now we use our
Like terms?
Okay, so now we should maybe say, all right, the point about fractions maybe is that I know that square roots play nice with fractions, right? So I can use the division rule or whatever it is to say, all right, this guy, the root of a fraction, the square root of a fraction is the square root of the top over the square root of the bottom, right? So I can replace that with square root of 20 over square root of 100.
Oh.
Wait, did I really just write square root of 100 down?
Instead of 10.
Oh, yeah, I know that one. That's just 10. Okay. Then I'll write the next guy down. I've got 3 square roots of 90 over 10. And I've got minus 7 square roots of 80 over 10. Then I've got plus
Nothing. Oh, 16.
square root of 160 over 10. Okay. Why would I keep the 10s instead of, like, say, canceling a 2 here?
Because you need a common bottom.
Yeah, because this is already in a common bottom, right? There's already a common bottom here, so I should resist the urge to cancel because common bottom is going to be convenient for me, right? Otherwise, when I try to add like terms together later, I'm going to have to go find that common bottom. I'm just going to undo the work I did canceling. So let me not do that. All right, so this stuff, what's my next step?
Write down the 20, 90, 80.
Okay, so I should factor out each of 20, 90, 80, and 160. Okay, and use the rule about square roots, right? So, all right, let's factor first. So what's 20?
5 times 5 times 2 times 2.
I'm going to call that 4 times 5. Why am I calling it 4 times 5? Yeah, because I know how to square root 4, right? I'm looking for things I know how to square root. So then I've got minus 3. Let's see, what's 90? 90 is 3 times 3 times 10. So I can write this as the square root of 9 times 10. Because I can square root the 9. The 10 I don't have any hope for, but that's okay. Sometimes you end up with square roots left over. Let's see, then I've got 7.
8 times 10.
Okay, wait. 8 times 10?
I would do the 5.
What?
5?
No. 5.
Okay, so let me think. I'm kind of thinking about 80, right? Okay, so 80 is
8 times 10.
8 times 10, which is 4 times 2, and this is 2 times 5.
You can also do 16 times 5.
Yeah, that seems like a better choice to me because I know the square root of that stuff. You guys see that? do this in a couple of steps if you've got to, right? Maybe a 4 out first, then realize that the other thing's a 20, get another 4 out. So I think I'm going to call that 16 times 5. All right, what's 160?
16 times 10?
That's 16 times 10. Very nice, Al. All right, and this is over 10, right? Okay, so now I use the multiplication rule for square roots, right? Say, okay, I've got 4 and root 4, root 5 over 10 minus 3, root 9, root 10 over 10 minus 7. What do I get on that one?
Square root of 16, square root of 5.
Good. Square root of 16, square root of 5, that's all over 10, plus
The square root of 16, square root of 5 over 10.
okay.
Now you
Okay, now I can do some bits and pieces, right? So I got 4
times
times 2 times, can't do anything with square root of 5, right? And all this is over 10. Then I've got 9 root 10s over 10. You can see where the 9 comes from?
Wait, what happened to the 3?
Is it negative 9?
So, yep, it's negative. So there's 3, and then root 9 is 3, right?
Oh.
So this is me saying 3 times 3 is 9. Whoa. Just like I could have done 8 here, right? Because 8 times 2, or sorry, 4 times 2 is 8. Okay, then I got minus 7 times
4 times
4 times root 5. And that's over 10. And then this next guy is what? 4 square root of 10s over 10. Okay, so what are my like terms?
A lot. 5 and 9 and 4 and 2.
Yeah, so this guy and this guy are like terms.
But where, the decimals on, we're not doing anything.
Yeah, we don't have decimals, we've got tenths now, right? But my like terms are, I've got these two guys with which have root 5s in them, right? And then I've got these two guys with root 10s in them, right? Okay, so combining here, I've got, let's see, how many root 5s are in this one? That's 8 over 10 root 5s, right? 8 over 10 root 5s. That's this first guy. Right?
Yeah.
Okay, so that's that guy. How about the other one? What's this guy?
Negative 20.
That's, right, I'm adding negative 28 over 10 root 5s. You guys all see that? You with me, Kev? Okay, so this piece, right, I'm writing out of order now because I'm putting the like term.
The numbers in front, like the 4 and the 7, we're including those over the hundreds now because they were.
They already were, right? This was 4 times this stuff divided by 10, right?
So.
Everything that's happening there is multiplication, so I can kind of rearrange at will. I just have to keep the things that are multiplied in the top and the things that are dividing in the bottom.
Okay, I thought I was keeping the whole numbers separate.
You are. 4 times this stuff is the same as 4 times the fraction.
Okay.
Okay, so I got 7 times 4 is 28. It's got a negative sign attached to it, so I'm putting that in here. And then it's got an over 10, and that's how many root 5s there are. You guys see that? Okay, then what are we doing with the purples?
You have to pull out the 4 and square root of
Really, I just want to write the purple stuff, right? Okay, so what's this one? That's, okay, so I've got plus negative 9/10 root 10. Yep, and then the other guy is plus 4/10 root 10. So that's this guy.
Why did you switch?
Why did I switch them? So I grouped the blues together and the purples together, right? Because the blues were the ones with root 5s in them,
Oh,
and the purples were the ones with root 10s in them. So now these are like terms, right? And they're together. So if I want to get the right answer out of this, let's see. Oops, black. Okay, so this whole thing is, all right, how many root 5s are there?
no.
There's two things with root 5s in them, right?
Right.
And there's 8/10 of a root 5 here, and minus 28/10 of a root 5 here.
So 2 root 5.
So that makes, yeah, 2 root 5s, really 20 root 5s with, maybe see what I lost there?
Yeah.
20/10 root 5. What did I lose?
Negative.
Yeah, there's a negative sign. I had minus 28 of them, and 8 of them makes negative 20 root 5s. Okay. And then the root 10s, how many of those are there? You guys see that? You've got 4/10 of a root 10 here, and then somebody comes along, takes 9/10 away. You have a debt of 5/10 root 10.
And that's it. Oh.
Almost.
Okay.
So what else can we do? What else can I do?
Could you reduce the fractions?
Okay, so we could reduce some fractions, or we could write it all over the common bottom. I think reducing the fractions is probably the more honest thing to do. Putting it all over the common bottom is not a bad idea either. I think, though, that this says I should probably cancel something at least. So if I canceled this guy out, what have I got? Yeah, that looks like negative 2, right? Yeah, keep the square root of 5. And then I've got minus, what's this guy work out to be? 1/2 root 10. You guys all see that? Cool? Okay, I'm good with you guys leaving it here. If you wanted to go one step further, you could. You could say, okay, this root 10, that's a root 2 times a root 5. And then you could maybe factor a root 5 out of this whole thing. But it's going to be a little bit, it's going to be a little bit ugly when you're done with that. I don't think it's better than here. Cool? In the end, with factoring a root 5 out, you would get something like root 5 times negative 2 plus, or minus, root 2 over 2. I don't think this is a lot better than that, so maybe don't bother. Cool? All right. Other things? Anything else on 48? So what was the trick at the beginning? Yeah, we were scared of decimals, so we put them into fractions. I'm really glad you guys have gotten to the point where you're like, we're scared of decimals, let's move to fractions.